This
MOEZ.
conference will now be recorded.
Okay, my name is MOEZ, and I'll be presenting integration of PyCaret in Power BI, Microsoft Power BI. So before we start, some laundry items. Can I please ask you all to mute your mic? If you have questions, please write them in chat box. We'll try to take all the questions towards the last 10 minutes of the session. This session is expected to be hands-off, so I encourage you, if you guys want to follow along, please do so. And if you have questions or you're stuck, we'll take your questions in last 10 minutes. All right, so let me share my screen. And if somebody can give me confirmation if you can see my screen. If somebody can write that in chat box, please. All right. Let me figure out how do I minimize this. Okay. I don't know. All right, anyways, let's get started. All right, thank you everyone. So today we're gonna talk about clustering in Power BI with PyCaret. My quick intro, my name is MOEZ, I'm data scientist. I'm based out of Toronto these days, but my background, I obviously started my career in Pakistan. By profession, I'm a chartered management accountant, but I have transitioned into data science since last 2 years. Last year, I started a project called PyCaret. I made it open source, and PyCaret is essentially an open source machine learning library in Python, particularly targeting citizen data scientists or business analysts or somebody who is in BI and looking forward to transition into more AI specific domains. So PyCaret is an open source machine learning library, which means it's free and it integrates well with so many BI tools. Today we're going to talk about one of it, which is Power BI, which is a very common visualization tool. I believe it has a wide number of user base and a very powerful ecosystem. Okay, so before we start, here are some key links about PyCaret. If you are interested in learning more about PyCaret, here's our website, our GitHub, and here's my LinkedIn profile. If you are having issues with PyCaret, the best place to get an answer to your issues is our GitHub page, which is this second link. There's a community that is actively working on GitHub, and your chances of logging your issue on GitHub and getting answer quickly is way more than if you were to message me directly, because I wouldn't know the answer of all the questions. So if you face issues, I encourage you log your issues on GitHub, and if you know the answers and you can help somebody, please do so. All right, so even this presentation is uploaded on GitHub. Here's the link to the repo. github.com/PyCaret and /PyCaret-demo-eb. Once you get to this link, you can get this presentation and all the other files that we're going to use today. All right, what do you need to follow along this tutorial today? So you need Python installed on your computer, Python 3.6 or greater. If you haven't installed Python before or you have never used Python before, no problem. The simplest way to do it is to install Anaconda distribution. If you go to this link, anaconda.com/product/individual, or just anaconda.com, you would see this page, which is basically, if you scroll down the end, you can download, if you're using Windows, you can download a graphic installer 64-bit. It's a 500 MB file, and it definitely requires some space in your PC. Once this is installed, and installation is really simple, you just have to click next. there's one thing that you need to know about installation of this is if you're installing it for the first time, this is the screen you would get at the end of installation. And you have to check this box, add Anaconda to my path environment variable, right? Everything else is just like a normal installation of any other software. And you would see once the installation is completed, you would get something like this Anaconda prompt in your start menu. All right, two other things that you need to follow along in this tutorial is obviously Power BI Desktop. I'm using May 2020 release. I encourage you to use the latest version, but it should work with the older version, as I've never seen issues with backward compatibility with Microsoft Power BI. So, but I do encourage you use the latest version. And then obviously you need PyCaret, which you would install in Python that you have just installed using Anaconda distribution. So Python is a language, and PyCaret is a package that will install in the environment that will create, and you definitely need internet connection for that. All right. Okay. So once Anaconda is installed, we'll do this. So we'll open Anaconda prompt. Right, I'll see if I can zoom. Yep, so you can see you would get something like this. Base C users, it would have your username instead of MOEZ, and the command that we want to execute is create an environment, which is the first line. Conda create name Power BI. This is the name of my environment, so I have named it Power BI. You can name it whatever you want, and the version of Python. So if you write this, Conda create name I'm not going to execute this because I have it already installed. But if you would run this command, it would take, and sorry, this is not one hyphen, this is two hyphens. So, conda create name Power BI Python. I have already created the environment, so I'm not going to run this command. It usually takes 5 to 10 minutes. Once you enter, it would prompt you for installation, so you just have to press yes and enter. But once this is installed, you can activate the environment. In my case, I have it installed, so I'll just activate my environment by typing conda activate Power BI. And notice as soon as I type conda activate Power BI, my base environment has changed from base to Power BI. And once you are in your environment after activation, what you need to do is pip install PyCaret, the third line of this code here in presentation. This would also take 10-15 minutes, but once it's done, you can close the command prompt. I'm not going to install it because I already have it installed. You can close the command prompt after this. Now, one step that we need to do is we have to link Power BI to the newly created Conda environment so that Power BI can connect with Python and PyCaret. In order to do that, I have my Power BI desktop file here. You go to options, then options again, and then under global settings, you would see Python scripting. And you just need to set a Python home directory by clicking browse button. And how do you get this directory? So normally on Windows machine, if you are using Windows, this is the environment, this is the path where it normally gets stored. Let me zoom in a little bit. This is the path. So this would be your username and then Anaconda 3. And let me show you quickly how it looks. So if I go enter MOEZ as Anaconda 3, envs, and if you see, I have two folders here. Let me show you two folders here. This is the environment Power BI that we have created, and this is the other environment that I'm using for something else. All right, so you just need to point it and then press OK. Restart your Power BI, and if there's no error, that means connection is successful. If you are using Mac and if you face issues in installing PyCaret, you should check out our pycaret.org/install page and scroll down towards the very end. There is some instruction from Mac users because PyCaret use Microsoft's LightGBM open source framework, and they have a different distribution settings for Mac users. So you have to build it using GitHub repo of Microsoft's LightGBM. Anyways, so assuming all this is done now, let me get back to presentation mode. Okay, so now we have Anaconda Python 3.6 or greater installed, check. We have a separate Conda environment that we created with those 3 lines of code. We have installed PyCaret, and I'm assuming we obviously have Power BI. All right, let's move. Okay, how are we achieving this theoretically, right? So almost any BI tools out there today gives you the ability to execute a Python and R script in their environment. And what it does is it basically, the front end of the tool would connect to some kind of path environment of Python or R or any other language. In this case, we have basically have a Anaconda distribution using which we have created a virtual environment in our laptop, which we named Power BI. And we have linked Python. We have linked Power BI to that environment by going into File Options and pointing out to that directory under Anaconda 3 folder. But what's so special about PyCaret is PyCaret has magic functions built in that would work in environments outside of a typical IDE or Jupyter Notebook kind of environment. That means these functions exclusively are built to work with these BI tools like Power BI, Tableau, Alteryx, KNIME, Informatica, and they are ideally to be used within the ETL pipeline. So you would inject it in the ETL pipeline, and the output from whatever you are doing, whatever type of machine learning problem you are doing, the output would be attached in your table. And where are we going to do this? We are going to inject this in Power Query. And what is Power Query? Power Query is a standard ETL tool for Power BI, just like Tableau Prep is for Tableau. There is Power Query for Power BI. What we are going to do is we would take the benefit of Python environment that is connected with Power BI, and we're going to execute a script in Power Query. That script will return you results that we are gonna then take back into Power BI and use it. All right. Used for batch processing. So I'm assuming this session is not very much about machine learning in broad sense, but there are two ways to generate prediction. Commonly, 2 ways to generate prediction in machine learning. One is batch processing. One is real time. Batch processing is when you have data table with many data points or multiple rows, I would say, and you want to predict them all together. So that's batch processing, but we'll not cover that today. Anyway, so there are quite a few articles about integration of Power BI and PyCaret, and there are use cases. So for example, there's an article on building your first anomaly detector in Power BI using PyCaret, and all these articles are very simple. And all of them are targeted to beginners. So doesn't matter whatever article you want to follow, it would always be from scratch. It would start from how to install and then move forward. So I encourage you, and they are 10 to 12 minutes read. So I encourage you to dive deeper in any of the subject you are interested in. But today we are going to specifically cover how to implement clustering in Power BI using PyCaret. So there is also an article about this if you want to read, but we'll basically cover the same use case that was in this article. All right, so we also have machine learning in Tableau with PyCaret, and we also have SQL. So if you are a SQL guy, I encourage you, you should definitely check this out. All right, before going into practically doing it, let's theoretically understand what is clustering and why would somebody do that, right? So clustering is a technique in machine learning used very commonly in machine learning, and what it does, it groups data points with similar characteristic together. There's a bunch of maths that goes behind the scene which would calculate the distances between data points, And based on that calculations, which basically encapsulate the characteristic of data set, it would divide the data set into n number of groups, or whatever number of groups you ask it to divide into. And organizing the data set in clusters is very useful, and it has some practical use case, such as customer segmentation. So imagine you are a retail store or any kind of service or product store, and you have a huge database of customers, and you want to design a customized marketing strategy or reach out strategy to your customers. Now, if you have 50,000 customers, you obviously cannot have 50,000 different marketing strategies. But what you can do is you can statistically, using clustering techniques, take that 50,000 customers and group them together, and then try to find pattern using those groups, find patterns, and then devise your strategy on devise your marketing strategy for 5 groups instead of 50,000 individual customers, right? So I hope you see what I'm saying. So this is a very practical use case. Also, let's say you are analyzing a pandemic outbreak like COVID-19, right? And you must have heard this word so many times, that a new cluster is diagnosed in this country, new cluster is diagnosed in this country. And that's not exactly the same, but pretty similar concept theoretically, that you want to be able to group data points together in like buckets or bins, and then you'd be able to understand or analyze those bins and be able to define your strategies. All right, there are several types of clustering: partitional clustering, density-based clustering. What we're gonna cover today, and each of these methods, so all these, when you hear somebody saying k-means, k-modes, or bridge clustering or agglomerative clustering, they are just different algorithms, and every algorithm has its own merits and demerits, has its own maths, has its own use case, has its own specifications. But k-means is a very common algorithm that is used in clustering. And what we are going to talk about today, not specifically about the algorithm itself, but whatever we will implement today, we'll use k-means to keep it simple. Right. All right, so going back for a second, remember here I mentioned an example of a store that has a large number of customers, and the objective is to devise marketing strategies to target customers specifically. And so you need to do clustering. So I have this one example, and this data set is uploaded on GitHub. And let me show you what this data set looks like. Let me just bring up my Excel here. Okay, not this one. Yep. Here you go. Let me zoom in a little bit. So this is a data set. Each row is a customer, and you can see we have 4 points, 4 data points on each customer. We have the age of customer, income of the customer, spending score, and savings. The spending score is some kind of arbitrary number between 0 to 1, and savings is savings. So we have this information about customer, and let's say we sell jewelry. At least in this case, we are selling jewelry, and we have to define some marketing strategies to target the customers. And while it is almost impossible to come up with 505 different strategies, what we can do is we can divide them into groups and see each group would have, hopefully would have discrete or differentiated enough characteristic that we would be able to come up with some strategy. Let's see what I actually mean, right? I'm gonna pull up a new Power BI file. This is, all right, so this file is uploaded. This file is uploaded here on GitHub, and you can use this link. Let me paste it in chat box. You can use this link to do a get data from web. So I would open my Power BI, and what I would do is get data, go to web, post this address. It should work. It would import the same CSV file that we have just seen. There you go. What you want to do here is click on transform data so that you go directly into Power Query. You can alternatively load and then click on transform, but I'm just going to transform. And this is your normal Power Query. At this point, remember you have an Anaconda environment where Python 3.6 or greater is installed. You have PyCaret installed there, and you also have linked your Power BI through options with that environment. And now we have this data set. We have imported it from GitHub, but this could be SQL table or CSV, or it doesn't matter where it actually comes from. Once it is here, we should be able to go to transform and then run Python script. And when this dialog box open, this is not an IDE, so you can imagine if you are writing Python in R code already, creating or importing a clustering model, training a model, and then returning labels of the model, attaching it back to the data frame is multiple lines of code. And now this is not IDE, so it doesn't tell you whether you are making the mistake in the code or not. One way is to basically write your code in IDE or Jupyter Notebook or debug it and then bring it here. But with PyCaret, because it's extremely low code, you don't even need to do that. So what I would do is, all right, before we do that, so one concept theoretically is any Python function needs a input, and that input would be basically the table here. And that input is stored in a variable called dataset. So if you are not coming from a programming background, no worries. Variable is basically something that stores a value. In this case, dataset is a variable which is storing the entire table, right? The first step is, well, import the module, import all from PyCaret.clustering import all. And obviously, if you can't see these lines here, all the articles have this, so you can instantly reach here if you want. And the second line is, I would just say get underscore clusters data is equal to dataset, and that's it. If I press OK, it would take a minute or so. And you would get something like this. And when you get this, you see this table, it's a hyperlink. You have to click on hyperlink. When you click here, you would see this new step being created. And this will return you a normal looking table. All right, while this is loading. Okay, so this is, if you see, this is exactly the same table, except that now we have this label attached to this table. Now, it's not just fitting, if you understand machine learning, it's not just about fitting the k-means model, it's also about handling entire pre-processing pipeline. What I mean by that is, you see how some numbers are in a different scale. So for example, the age is between 17 to 97, while income is obviously in thousands, right? And spending is scored in decimals. So for clustering algorithms, this is not a good thing. So we do something called normalize. That means change all the numbers between 1 and 0 by using some form of standard scaling. So PyCaret does all that under the hood, even though you may not see that these numbers are changed, but what we have done is under the hood created that entire transformation, did that, and then only attach the label back to the data frame so that you don't lose any information and your output is still human readable output. If we were to do it in a normal way, that would mean that we would have converted all these numbers into between 0 to 1, and it's kind of meaningless for your business because they don't know what that number means, right? You have lost the original scale of that. So in this case, we keep the original input human readable and just attach the label back. So let's close and apply. And okay. All right. And at this point, this is nothing but a normal data table in Power BI, right? And how I'm gonna use that. So if I go back, I can use this and filter. And if I just for a second drop in my income, and I would make it average. So you can see all the customers in cluster, and this is just an example. We'll see a more comprehensive demo after this, but this is just an example of how would you use this quickly. So all the customers in cluster 0 has average income of $27,000. Cluster 1 is $72,000. Cluster 2 is 107. Cluster 3 is 128. So customers in cluster 3 are the richest customers, right? And if you do it with multiple dimensions together, you can actually start making sense out of it. So all the people in cluster 0, they have average income of $27,000 and average age of 87, which means looking at the income and age, we can infer that these are most probably customers who are retired. Cluster 1 is 60 years on an average and 72,000. So I would say mature professionals or maybe nearing retirement. Cluster 2 is seniors, 41 years of average age and 107,000 of income. And so cluster 3 is probably millennials with the average age of 24 and 128. Now imagine this data set is from a bank or any service company where they have to target products or services based on age and income. So very common example would be insurance companies or investment companies or investment portfolio companies. They would want to target their customer based on the product. So somebody who is retired with only $27,000 of income, those companies don't want to spend huge in marketing to these customers because they won't buy their products, right? So that's the whole idea behind clustering. Okay, now that we have seen and built a basic intuition, let's take more practical use case. So all right. So, this is a use case, and this is what the article is all about. So you can also read that, but we'll also practically see this use case today. Let me close my files. Okay. All right. So this is the data set that I have taken from World Health Organization Global Expenditure Database, and this data set has last 18 years by country. And if you can see, we have about 200 countries, and we have data points from last 18 years. And these numbers are basically percentage of GDP spent on health. So what percentage of total national GDP is spent over health? So what this 0.09 for Afghanistan would mean, 9% of total GDP of Afghanistan was spent on health in 2000, and then 9.4 in 2001, so on and so forth, right? And it has 200 countries. What I wanted to understand from this data set is what's the pattern in the data set, which countries are spending very high, which countries falls together and stuff like that. So you can take this data set again in the presentation, on my GitHub page. And if I show you GitHub page, you would see this repo, PyCaret-demo-eb. You would see this clustering.csv file. That's the data set if you want to use. And there is a Power BI file as well, which is clustering in Power BI using PyCaret, which we are about to see. And let me open that for you now. All right. So I think in terms of time, we are looking really good. So I think we'll also have opportunity to quickly see anomaly detection, which is used for detecting outliers, and it's pretty similar to clustering. So I think we'll have time for that. It's 12:32 now here, and we have 28 more minutes. So let's try to finish up the demo in next 18 minutes, and let's keep last 10 minutes for Q&A. All right, while this file is opening, so this is just the front end that I have built using the result of clustering that I get. Remember the cluster label column I've shown you, right? So similar concept, exactly same concept. I have this data set here, which has this cluster column. And how did I get cluster column? Pretty much the same way we have done for jewelry. So let me just show you what I've done here in my Power Query. All right, here's the Python script. And if I show you this from PyCaret.cluster import star get underscore clusters data is equal to dataset. Why dataset? Because the input table is mapped into a variable name dataset. And then ignore features is equal to country because I don't want Power BI. Oh, sorry, I don't want my clustering algorithm to use country variable as part of the calculation. I've also passed num cluster is equal to 5 because I was using this data set in Python for some other analysis. I knew for a fact that the ideal number of clusters is 5 on this data set. There are techniques available to find that, not part of this session, but there are techniques that can help you make a good approximation of what should be the ideal number of clusters. Anyways, as soon as I run this code, I get this. This is what I get. This is my original data set, and then I have a cluster column here. Then I have normalized this to convert it into this shape, which is basically instead of all the years in the column, I wanted it in years. So basically I have unpivoted all the years and normalized my data set so that I can consume it in Power BI. In my case, the visuals that I wanted to build, I wanted to do a little bit of time series. In my case, this is how I wanted this to be. That's why I have unpivoted and normalized the data set. Now going back to the dashboard, the way I have used this is in all the visuals and everywhere we have used cluster as our, I would say, as something we've faceted over. That means it's a legend or it's kind of a segregator. So in this map, you can see these different colors would represent different clusters. You can see the legend. And if you look at this graph, this basically, let me see if I can zoom in a little bit. If you see this graph, this shows all the countries in cluster 1 is spent on an average 14% of their national GDP on health. And if I filter cluster 1, I'm guessing it should be US. Yeah, it is US. You would see countries in cluster 2 spend only 3.2%. If you see those countries, unfortunately, India, Pakistan, and all these countries, right? And on second page, you can more specifically look at the country level. So you can use this to basically look at countries specifically. But all this design and front end has actually nothing to do with clustering. The only thing that you get is a label, and then you can use it in whichever way you want, right? All right. So we have another 15 minutes. So let's now see anomaly detection, which is pretty similar idea. Uh, and this is the data set from state of Delaware, so in US. So companies normally would give corporate credit cards to their employee to do company expenditure. And there are many people who get that credit card, and the system is normally automated. You make company expenditure, you submit the receipts online, it get approved, pass through the reviewer process and gets approved. So normally, what you can do is kind of flag transactions that there are outliers, that require maybe that may require more human efforts to review them manually, right? That's one use case. So I have taken these credit card transaction, which is an open source data available on the state of Delaware website, and I have basically each row is a credit card transaction. And if I show you the data set, this is basically, oops, that's not a very good way to see. Let me open up Excel. Okay, so this data set is basically the year and the period of transaction, name of department, name of division, which merchant, category of expense, date, and the amount, right? And based on that, our use case is this data is Power BI is connected to some kind of SQL warehouse or any other warehouse, and this data is being pushed every night into the data set from some kind of transaction system, such as SAP or anything else that your organization is using. And you are kind of visualizing this data set in Power BI. You're producing reports or dashboard out of this. You can use PyCaret's get outlier, inject it in ETL process, and basically get a flag, which would be 1 or 0. 1 would mean it is outlier based on the data set that you have given, and 0 is not an outlier. And the way, similar to clustering, the way we detect outlier is there are a bunch of algorithms: isolation forest, single support class vector machine, and every algorithm has its pros and cons. And we will use something really simple today. It's called isolation forest. And every algorithm has its own way of finding out or classifying outliers. Um, Let me open up this file. So you can also get this repository. It's named Power BI-Anomaly Detection on GitHub, and you can download this PBIX file as well. All right, so the same concept. This is the front end. You can build it whichever way you want. Obviously, the application I was just talking about is somebody on front end would have this table where there are all the transactions, and then we have this flag of outlier 1 or 0. And even if I just read this, it would make sense to you. If you look at the rows here, it would make sense to you why this is outlier. Not necessarily this is correct, but remember, this is just a attempt to flag outlier. This doesn't surely means that this is a fraudulent transaction. This is just flagging it as a suspicion based on the distribution of all the data points, right? So this is not a guarantee that this is a fraudulent transaction. Just want to make sure you understand that. But this is a statistical way to tell that this is outlier, which means this is structurally different than the other data points in the data set. Right. And the way we achieve this is pretty similar. If I go into Power Query and I show you, it's a pretty much same script. So you'll just replace the word clusters with outliers. I'll show you Python script here. You can see get underscore outliers dataset, and in this case, I'm ignoring date, merchant, and department name because I didn't want to use that for this analysis, so I'm ignoring it. And at the end of the day, what you get is a dataset with a label, and this is how it looks like. Excuse me. There, label column. 1 or 0, and you also get a score column. A score is basically underlying calculation of label. So this is how the label is decided. You may or may not use a score. In this case, I have used a score to kind of show the magnitude of outlier. Anyways, so I think that's it for today, and I think we'll be open for questions now. We have 20 minutes, so that's good that we can take questions. All right, so I'm in the chat window, and I will be reading questions and answering it for next 15-20 minutes. So I meant writing code, which was. So Deepak asked, can I also run supervised ML models in PyCaret? For sure, yeah. There are 6 modules in PyCaret, Deepak: classification, regression, clustering, anomaly detection, NLP, and association rule. So you can do that. You should definitely check out our website, pycaret.org. And yes, and if you meant to ask if we can use supervised learning in Power BI, then yeah, you can have your model pre-trained in any IDE or a Jupyter notebook and save it as a pickle file, and then you can load that pickle file in Power BI. You can do that. There are tutorials available on website for that. You should definitely check that out. When installing Power BI to Conda, get this message: the following packages are not available from current channels. Right. So Mohammed, we need a full traceback to see what is actually wrong. So I encourage you to log a ticket on GitHub with a full traceback message, and we'll be able to understand. How do I deal with an imbalanced data here, Deepak? So again, a good question. If you are referring to imbalance target variable in a supervised machine learning problem, then there's no because PyCaret is based on cross-validation, there's no technique at the moment to deal with it other than that you undersample or oversample before bringing the data into PyCaret. Also, is there any accuracy info? So we have covered unsupervised use cases today, clustering and anomaly detection. There is no accuracy in that. But yeah, if you were to do supervised learning, then obviously there is accuracy, AUC, recall, precision, F1, kappa, and MCC that you can see. Do Google search, download Power BI, you'll get it. What's a Mac alternative for Power BI? I don't know. I think I don't know if Power BI doesn't work in Mac. Which giants are using this library? I don't know about giants, but there are about 100,000 users of this library, and most of the companies that are using this are either boutique consulting or some form of consulting, and they're using this for rapid prototyping. Will you share the presentation? Yes, the presentation is on the GitHub repo. So if you go into demo-eb, you would see this PPTX here. Does PyCaret support deep learning? No, nope, it doesn't. Thank you, Raheem. So I think we'll give another 2 minutes. All right, so Rahim is saying for using Power BI in Mac, you can visit, yeah, you can see Patrick's channel, Guy in a Cube on YouTube. He has some videos. How can we make elbow chart analysis for determining number of clusters? Very good question, Mohammed. Uh, yeah, so if you, let me show you pycaret.org/clustering, and you can see this is a sample code to plot anything in PyCaret. Just one word, plot underscore model. And you would see there are many options, and definitely elbow plot is there. So basically plot underscore model, and you'll just pass in your model, and the type of model is elbow. So it's really simple. There are tutorials on websites, so I encourage you to check those. There are notebooks. Thank you, everyone. Thank you. Do we support? Right, we'll give another minute, and if you don't have, can I generate random forest with PyCaret? Yes, Chris, you can. So I think there's a lot of interest in supervised learning here. So if you go to website pycaret.org and then go to modules. I'm having difficulty here because of go to meeting here. So if you go here into modules and look out for modules, today we have done clustering and anomaly detection, but if you go into classification or regression, you would basically see the documentation, and you will see how to create a model. In this case, you can see create underscore model. You'll see a sample code. You'll see an output of what you get. So because it's supervised learning, you get accuracy, AUC, recall, precision, F1 kappa for at tenfold validation. Do you have any demo in NLP using PyCaret? Yes, we do have. So if again, going back to website, if you would see tutorials here, and same thing in tutorials, you can either go to beginner level or intermediate level. Let me show you an example of NLP tutorial. You can either open this in Google Colab, or you can see a source code on GitHub, or you can download it. I will show you here on Explorer. So this is the tutorial, very basic. It's from scratch. So even if you're starting, if you're very new, brand new, I think you should definitely start from here. It would take you step by step, some theoretical knowledge and all the interactive plots and stuff like that. So, and obviously we have tutorials for all the other categories as well. So you can actually go and see tutorial for any of these modules. Mohammed asks, k-means cannot handle the large data set in Python or R. Can we solve that problem in Power BI? No, unfortunately not, Mohammed, because Power BI doesn't have its own implementation. What it is doing is actually using the same Python environment behind the scene. So if you have any problems with specific algorithms in Python or R, it would definitely exist in your upstream systems as well. And as far as I know, I don't think so. Power BI has its own implementation. Okay, let's see if you have. Thank you, Mayor. Thank you, Mahesh. Thank you, Ahmed. Does PyCaret support regularization like Lasso and Ridge? Yeah, it does. So do check out our website, pycaret.org. It has over 60 open source implementation from Lasso and Ridge to CatBoost. So it has over 60 open source algorithms, including CatBoost, scikit-learn models, Microsoft's Light GPM framework, Spacey, quite a lot of things. All right, thanks. All right, so I think if that is it, Raheem, can we call it a day? Thank you. Thank you.
Yes. Thank you so much.
All right, thank you, everyone. Have a good day. Bye.
This conference will now be recorded.